When we're designing or modifying a laser system, it's important at the very earliest stages to go through the risk assessment and try and work out where the main hazards are and where the risk is going to come from. To do this, it's best to go to the lab, have a walk down, look at where the doors, the windows are, where the services are going to come from, and see how much space we've got available and what equipment. So in this demonstration of a quantum eraser, we've got a laser here, a diode laser, which is firing through a beam splitter. The primary beam is reflected off this mirror here and goes onto a stage here. The secondary beam is coming off the beam splitter here, hits the mirror, and is reflected onto the second screen over there. Inside the beam path we're going to place a number of polarizers at various points, but the essence of the system is just the two beams, so we can forget about this part. We are only interested in the main components. So, having had our walk down, we've looked at the system. Next thing to do is produce a schematic. This will actually help us to visualise the risks and design our risk assessment around those. So we have our breadboard here, and on it we have our laser, first beam splitter here, mirror there, mirror off here, and there's another beam splitter in here, and we have our two stages. So the beam's going to go through the beam splitter, reflect onto the stage there, secondary beam comes off here, goes onto the stage there, and we know we're at 532 nanometers with our diode. And for the purposes of this demonstration, let's just assume it's a class 3B laser, and that means that the specular reflections are going to be hazardous. Okay, so what else have we got here? Well, we can see we've got a door over here, opening that way, and we've got a window over here with a low casement. So that means that if we lose a beam or a reflection from our system, there's a risk it could hit the door, or someone come into the door, or it could fly out of the window. So having got this schematic here, we can now go back to the desk and work out how we're going to place this laser. Now, straight off we can see with the door and the window we've got issues here. However, the compromise is going to come because whilst we have a laser running from the back end of the breadboard here, our hands are always going to be moving away from the beam. If we have the laser running this way, then we're going to be placing our optics with our hands potentially running into the beam. So we know we've got to do some reorientation of this system.